I told you that in order to solve this issue of lost multiplicity information, there were lots of things which have been conducted. And I told you that there were experiments like spin-echo Fourier transformation or EPT, attached proton test, through which you can हाँ मुझे दे दीजिए. Through which you can obtain information about the multiplicity. And remember I told you that even a simple molecule like alpha-pinene, you can have convolute a very difficult spectrum. And on the other hand, when you fully decouple them, then you get information about the chemical shift and number of carbons, but at the same time you lose multiplicity information. Okay, we go further. This was the diagram which I was trying to convince you to understand, and I told you that this is an extremely interesting situation in which you can modulate the multiplicities with reference to their evolution in XY plane. If I just tell you that this is the scale from 0 to J, then you have a different time frame, and you can multiply the whole thing in terms of a time too. So you can say that this is the time from this when you convert a longitudinal magnetization vector into a transfer magnetization vector to the point when you read them is let's say 7 seconds or whatever, 8 seconds. And I told you that in a system like this, when you have attached protons like CH, CH2s and CH3s, the evolution, the modulation, because of the coupling with the proton, the frequency of the splitting of these signals are different from each other. So for instance, when in a rotating frame of reference, the quaternary carbon remain at this position, you find that one has a doublet has actually evolved into two components. One is a contour rotating component, one is a slow moving, and the other is fast moving. The CH2 split into 3 different components, and CH3 convert into 4 different components. Now, after a certain period of time, you see that these are actually reached to a stage where they are moving contour rotating, and when the full cycle of this has actually taken place, if you say that this is from 0 to 180, then you would be able to see something extremely interesting, which I want to show you right now. You see in this, if I tell you that this is the time delay in terms of an angle, then you would be able to appreciate that at the end of the signal, at the end of the full delay, you would be able to see quaternary carbons, CH2s on one face, and CH3s and CHs on other face. One thing which I forget to tell you, that there are lots of interesting variation in between, which I want to go back and revisit the whole thing. For example, between 0 to 180, or a time between this to this, exactly at half of it, you would have a situation in which you would only see the quaternary carbon. And if you don't believe me, I want you to see this again. This is the half situation, right? And you see what is observed by the detector at this point of time. If you turn on the detector, you would see only the quaternary carbon. The other are cancelling absorption, and you see that these components are not visible because they are cancelling each other, right? So at a particular duration, you would be able to see only the quaternary carbon. The purpose of telling you is very simple, and that is that by using a modulation of because of the coupling of proton, they move differently on XY plane, and as a result you can see them in different phases. So forget this thing, and we move forward to spectrum like this. And I told you that in a situation like this, you would have perhaps a fully decoupled spectrum. Then you would have a spectrum